Yes, now welcome to today's lesson. Today I've prepared for you a unit known as vector analysis. Specifically, I want to concentrate on dot product. With me, I have a question here that I want to help you on how we can solve the problem. So the question is that is given that vector A is equals to negative 4i plus 3j minus 11k, and vector b is equals to I minus 3j plus 6k. So the question is find vector a dot vector b and then find the angle between the two vectors. Yes, so that's what the question wants you to get. Now, first of all, you've been told to get the dot product, that is vector a dot product vector b. Now how can I work out that? Because after working out that, we will be in a position of getting the angle between the two vectors. Now to come up to that, let us write solution here so that we can see how we can work out that. So that is the solution. Now to begin, I'm supposed to be getting vector a dot vector b because that's the dot product. The dot product is just a dot, yeah. So as a result of this dot is where now the name arises. So the name arises from the dot we normally put here. Now how can I perform this? First of all, you are required to be getting you are supposed to write that is negative 4i plus 3j minus 11k. So you write the coefficient of I, j and k there in this manner. So you just come and write negative 4, that is 3 as well, that is 11. Yes, in that form. Then you just write, you can intend to put a comma there to separate those coefficients. Then just put a bracket there because we want to see how we can work out dot product. Then on the second hand here, the coefficient of I, j and k in b, you're supposed to write them in column form. Remember, in A, I've written in row form, but in B, you're supposed to write in the column form. Very important. So when I come to the coefficient of I, j, and k in B, the coefficient of I is 1, so I'll come here and write 1. Coefficient of j is negative 3, so you just come here and write negative 3. As well, the coefficient of that is k is 6, so just come here and write 6 there in that manner. Now after that, you are just supposed to now begin multiplying. So when I take the method is always goes that you just take a row by column. So just take a row by column. So you shall just take that is a negative 4 by 1 plus 3 by negative 3 plus negative 11 by 6. You work out addition, then arise to your final answer. That is it. So when you do such, I should just come here and say, now this one is equals to, that is negative 4 by 1. And what is negative 4 by 1? That is negative 4 plus 3 by negative 3. That is probably is negative 9. So minus 9 plus, remember the sign in between is addition. Then when you come here, negative 11 by 6, that is negative 66. So I'll come here and write negative 66. Now after this, you are supposed to now work out. So I'll remain with negative 4. Positive by negative is negative 9. Positive by negative is negative 66. Of which, when you work out negative 4 minus 9 minus 66, you will end up by getting that is negative 79 as your final answer there. Now after getting that is the dot product which you've been asked here, you are now supposed to be getting the angle between the two vectors. Yes, so you are supposed to come and write the angle between the two vectors. Now how can I get the angle between the two vectors? So I want to give you the formula that will enable you to get the angle between the two vectors on dealing with the dot product. Remember, we have dot product as well as the cross product. So the formula is different with a slight change. There's also only a slight change. Now here, under dot product here, the formula goes that you are supposed to now just take the vector A dot vector B, which is equals to the magnitude of A times the magnitude of B cos of theta. That is it. So that's the formula you are supposed to be getting. Now, since we've gotten that is a dot product of A B as negative 79, I'll be in a position of getting now the magnitude of A, because I can get the magnitude of the coefficients of I, J, and K in A. Then I get the magnitude of B, I, J, and K in B, which are these ones. Then from there, I'll be in a position of getting the cos theta, which shall be very easy to get. Now, first of all, let us get the magnitude of vector A. So these are vectors. Now, how can I get the magnitude of vector A here? To get the magnitude, the formula just goes there. Just take the square root of the coefficient of I, J, and K, each you square. So you come here, the coefficient of I is negative 4. So I'll just come in and write negative 4, but to square everything, plus the coefficient of J, that is 3 squared, plus the coefficient of that is K is negative 11. So just take negative 11, then you square it. That is it. Now, when you work out that, you will realize that probably the negative 4 squared, that is 16, because I'll be remaining with 16, plus 3 squared probably is 9. Then I get negative, that is 11 squared, that is 121. So you just take 121. When you do such, you will end up by getting 146. But remember, on getting the magnitude, you get the square root of the result. So you will finalize by getting the square root of the answer there to be 12.08 as your final answer there. Now, after getting the magnitude of A, remember, I need to be getting the magnitude of B. Yes, so the next step here is to get the magnitude of vector B here, whereby now the magnitude of B, the formula just states the same way as we've done in vector A. Now here you just come at the coefficients of I, J, and K in B, then you just square each term, then you add. So you just come here, the coefficient of I was 1, so I'll come here and write, so 1 squared, then plus the coefficient of J is negative 3, so I come here and write negative 3, but I square, plus the coefficient of K is 6, so I'll just come 6 squared there. Now when you do such, you will end up by getting 1, negative 3 squared, that is 9, so plus 9, plus that is 6 squared, probably is 36. When you do such, you will end up by having 46, of which when you get the square root, because we are dealing with magnitude, you shall end up by getting your answer as 0, that is 6.78 as your answer on the getting the magnitude of vector B. Now after getting the magnitude of vector A as well as vector B, your work is just to substitute, because already we have the dot product as 12.08, the each and every magnitude we have. So your work is just to substitute. So I'll come here and say we were getting the magnitude, the dot product of vector A and B. And what is it? It is negative 79, remember? So I'll come here and write negative 79, which is equals to, now here, I've gotten the magnitude of vector A. And what is it? It is 12.08. So just substitute. So where the magnitude of vector A is, just substitute with that is 12.08. So I'll come here and write 12.08. Then the sign in between is a multiplication. You may intend to use a bracket to separate. Then the magnitude of vector B, we've gotten as 6.78. So that's what we write. So you will come here and write 6.78. Then remember we have cos theta, very important. So just come here and write cos theta, because we want theta here. Now after that, you are supposed now to simplify your work. By so doing, you can intend to divide by 12.08 times 6.78, so that you remain with cos theta on one side of the equal sign. So when I do such, I'll take 12.08 times, that is 6.78. On this other side also I do the same, 12.08 times 6.78. Now when you cancel such, this one goes, you will remain with cos theta on 1 equal sign, because cos theta is here. So I'll come here and write cos theta now being equals to, now when you simplify this, probably I'm having, that is 6.78. When I multiply it by 12.08, I'll end up with something like 81.93, of which when I take negative 79, when I divide it by the denominator, I'll end up by having, that is negative 79. When I divide it by my result on the denominator, I'll end up by having, that is a negative 0.996. Sorry, it is negative 0.964. Now to get theta, it is now very simple. You just get the theta, which is the cos inverse of the result. So you'll just come here and write the cos inverse of negative 0.964. Now when you work out that, you will be getting the cos inverse of your answer, of which the cos inverse of my answer shall be, that is theta being equals to 164.6 degrees as my value of theta. Now friends, after reaching your final answer to the provided equation up here, because I was asked to get the dot product as well as the angle between the two vectors, you shall have end up to get the solution to the two problems. Otherwise, you've seen me stressing some of the major areas that you need to adhere to so that you don't miss whichever way. So ensure you mark each and every concept, each and every area I've stressed on, so that you excel in dealing with, that is the dot product under vector analysis. Otherwise, let me meet you in the next class.